Hello everyone, and how's it going? Today we are going to look at how Redis can fail at scale, and we are also going to look at number of practices on how actually to use Redis. Okay, so let's get straight into it. First of all, we'll look at what is Redis. Redis is an in-memory database, right? The critical part here is in memory because most of the databases are persistent storage, so they are like hard disks like Postgres, MySQL, and other ones. But Redis is in memory cache, so whenever you want to access some data it is really fast. Like if even the highest or the most performance will be like if you're going to fetch it from the database, it will be at least 50 ms. It can be 5 ms in some cases, but it has to be like very minimal kind of database or very smaller query. But if you're fetching it from the Redis, it will be like 1 ms, or it can even be smaller than that. But on an average from DB it will be like 50 ms, and from your Redis cache it would be like 5 ms. Like that much of a difference you will get for like the same proportion or complexity of data that when you're fetching. So Redis stands for remote dictionary. It is literally key value pairs that we try to store, right? What are the risks? When does Redis actually fail? What is Redis actually is not built for? See, Redis is built for smaller keys, very small keys. What is the size of the keys that is, you know, Redis performs really well with is like keys sizing very small, like in bytes, in hundreds of bytes, max to max. 100 byte 200 bytes works very well with Redis. It can scale to even 1 million requests per second. That's very huge. 1 million requests per second is very huge. But if you keep the size of the keys very small, and also your eviction policies and everything also, we'll come to that also. But if you keep the key size is a very important factor, because you need to understand that Redis is single threaded. Now that is what makes Redis fast, because it doesn't have to have bear the overhead of managing multiple threads, but and also managing the logs, like what it is writing and switching the context and everything. All that overhead and everything is gone. It is just single threaded. And despite being single threaded, how does it manage multiple clients? Like if it is engaged to multiple clients, how do those multiple clients send data to Redis at the same time? It is by OS level thing, that whenever a particular client wants to send data to Redis, it will write into the file descriptor, and Redis will internally will get a kind of notification from the operating system that somebody wants to write to Redis, and it will just take that data and write to it. Why Redis doesn't work great with big keys? See, whenever we want to write a key, first of all we have to fetch the key. So if the key is like 50 bytes, 100 bytes, it gets fetched in one attempt, right? Like in one pass, or in one packet, or one transaction, or you can say in very few transactions or very few packets. But when data is like big, 1 KB is massive amount of data as a key value pair for Redis. Have been cases where I have seen in production even key value pair of 1 MB, people trying to store the like preview of a PDF or something, which expands to even 2 MBs, which is horrible practice to have for a production database with Redis. Now, why it is bad is because, first of all, it has to maintain in memory a buffer, a temporary buffer, in which it has to first fetch the entire key into the memory. And then it will persistently, as in nothing is persistent here because it's in memory, but it won't update the actual Redis dictionary until it has the complete key value pair. Like let's say if you're sending a big key which has 50 character, like let's say 50,000 characters, So once you have 10,000 characters, you cannot update the Redis dictionary. You have to fetch the entire data and then you will update the Redis dictionary. In addition to that, whenever you have these bigger keys, it will also spike your bandwidth for the Redis, which is also a critical factor. Bigger keys. Every time you write the key, then when you have to fetch the key, the same thing happens. You will have to have more packets, more transactions to fetch a particular key. Again, more bandwidth is lost. Bigger keys take up way more time of Redis, which is why it is not the most ideal practice. Next up is having very big TTL and no TTL. I have seen data like it very happens, it's a very common mistake to have keys in your production database with no TTL at all. And whatever is your eviction policy can actually lead to a really bad disaster here. Because let's say if your eviction policy is that no new data should come in, like what happens when you hit 100% usage in Redis? What would you do? Do you want to evict the existing keys, or do you want to give an error when you try to write new keys? By default, there will always be a policy set up in your Redis. It will be set up by AWS, some kind of default, or if you are managing on a different cloud, it can be some other default setting, but there is always a default setting. And as we scale and as we hit more edge cases, you will always find these default settings are kind of our custom choices, because those are the decisions we took by not taking decisions to change those default settings, right? And let's say your default setting is that you will get an error when you're writing a new key after 100% usage is hit and you have keys which have no TTL. This scenario can happen maybe 5 years, 10 years later, but one day your system will completely go down because you might be managing session management, your OTP management, and critical things which are dependent on Redis, which more or so ever happens. And we always, ideally have to have a behavior where your 80% of the requests are, catered by your cache and CDN, which is your 20% of the data, right? So those 80% of the requests will then go to your database and servers and make more processing and CPU processing. First of all, you might not be able to might not be ready for that level of data. Second, even if you are ready for that kind of data, it will cost you a lot what it should have in case you would have had better practices. So that is about having big TTLs and no TTLs. Another thing is having TTLs too small or collision of TTLs. Like let's say you have a lot of keys which are expiring at the same time. Expiring, collecting garbage, this is also a very kind of heavy activity. That is one thing, but it happens asynchronously, so that is fine. But second thing is, once you will have a lot of keys expiring at the same time, you will have a lot of cache misses at the same time. That means a lot of load will go to your um, DB and your server to compute more of the data and processing and more API calls within your system to other microservices. That will actually explode potentially, and this will consume a lot more of your resources than it should have. uh, Next up, like I mentioned, your eviction policy is very important when you hit the 100% usage, because it can happen that you have eviction policy that you get an error after you hit 100%. LRU is the ideal in most cases, but in some cases, like you might have keys which are like, let's say, which has TTL of 6 days, but you hit 100% usage. Now, if you want to evict that key might have been like just 5 days old, and now you evict that. You are going to face a problem where you are just putting the keys into the cache and just evicting them out without, because you are just keeping them and pushing them out. So it will start becoming like you're adding one key and popping off another key, and that previous key was not even there for even like few seconds, while its TTL was like in days or weeks. It can happen. While ideally our TTL in Redis cache should be very small, like I would suggest you to keep it within a day, max to max. You have to keep, you have to plan for scale, you have to be ideal. That is with the eviction policy. Now, monitoring Redis is very difficult. It doesn't matter what you use AWS or GCP or Azure. There are no out of the box tools for monitoring Redis. Because if you add monitoring on Redis, you would be like consuming more resources of the Redis itself. Redis is not running on a server. Redis is the server. It's an in-memory database, right? That is why if you will add more monitoring, more logging to know what is happening, even asynchronously or synchronously, it is going to cost you a lot more, not in terms of money, but in terms of latency, in terms of CPU resources, in terms of consuming your bandwidth that should actually be used for catering the request of your customer, but you're using it for logging and monitoring. That you wouldn't want to do. But obviously, monitoring and logging is also important, which is why you can always sometimes turn on monitoring using the monitor call and observe how your system is behaving. Right. So that's are all the points. Now, the important point is just to summarize at the end of this video is if you're using Redis, make sure 100% make sure that the key size is within 100 to 200 bytes. If it is around a KB, you can always compress them, reduce them, bring them to like 100 and 200 KB. If the keys are still bigger, like if you have keys of 1 MB size, split them. It must be a kind of data that you can split into smaller chunks, and you might not be using 1 MB of data in your API response call. That normally doesn't happen. A general standard API call response is within KBs, so it doesn't make sense that you would be using the entire 1 MB of data from your Redis cache to like in your API call response. Break it down, reduce it into bytes preferably, never in KBs or MBs, though like that's horrible. Plus, if you're trying to store things like blob, like image or a preview of some PDF, even compressed form, that's a bad practice. Just move it to CDN, move it to S3, whatever you want to do, but don't keep it in Redis cache. Okay, so that's how you use Redis cache, what to store in Redis, how it can break easily, even not at a very good scale. If you keep like keys bigger, like big as 2 MB, 3 MB, then not even at scale, like even at a moderate scale, your system can go down easily. Good enough. Okay, so I think that's all for this video. See you in the next one. Let me know in the comments what you think about this video or what you learned, what you want me to make the other next video on. Thank you.